All right, welcome to 5.3 normal distribution, finding values. Our SWABAT is finding a z-score given the area under a normal curve, and we're going to transform a z-score to an x value, and then finally we're going to find a specific data value of a normal distribution given the probability. Example 1. Find the z-score that corresponds to a cumulative area of 0.3632. So if they say cumulative, you're automatically looking for the area to the left. So it's a direct thing where you're looking for your table. If you don't have your z-score table, you might want to go ahead and grab that because I'm going to be showing you some stuff that might not be on here. So you can press pause and grab that if you'd like. So I will just go to my thing. It's 0.3632. And you're basically just trying to search and find. Because it's less than 50%, I know that I'm looking for the left side of those z-scores, the ones that are in the negative range. So you're just going to look, and then finally you find 0.3632. So you're just searching 0.3632. So then you're trying to figure out, okay, well, what's the z-score for that? It's negative 0.3, and then you need the 100th spot. So I'm going from here, and then I'm looking straight up. 5. And that's it. Z equals that. Okay, let's try another one. Your next example, really that's all though. Your next example says find the z-score that has 10.75% of the distribution's area to the right. Now the thing about this is this whole part where it says to the right, that's an issue because all of those values are based on the values to the left. So what do? Well, we know that the whole chart is 1, so I'm going to do 1 minus, changing this to a decimal point, 0.1075. When I subtract that, I get 0.8925. That's more than half. So because that's more than half, I'm going to be looking at the positive numbers for my chart. And again, I'm looking for 0.8925. You're looking, and the numbers are organized so they get bigger, and this is it right here. So you look at the area to the left, it looks like it's at 1.2, z equals 1.2, and then for the 100th spot you go up 0.24, 1.24. There you go. Okay, next. That's a mess. Let's fix it. So for your next example, find the z-score that corresponds to P5. Now when it says P5, kind of important. That's like saying percentile. So you're looking for the 5th percentile. And when they're talking about 5th percentile, you want to find 5% below that area. So what's great about percentiles is that it's always going to be, so let's look at this. 5 is like 5%, so it's in the 5th percentile. You move it over twice, so I'm looking for 0.05 when I move the decimal point over to the left. So what would that be? Well, you're again going to go to your chart, and I do want you to like legit do this. So press pause and do that for me right quick. Okay, so you did that and you found that it's not exactly there, but it's dead smack in the middle of the values that they had for negative 1.65 and negative 1.64. So to find an accurate z-score, I'm going to find the average of these two. I'm going to add them together and divide by 2 because there's 2 numbers that it's between. Then you'll use your handy dandy calculator and you'll get negative 1.645, which, if you're thinking about it, that's right in between those. So that would be the z-score for that one. The key thing I want you to remember here, because it's notation, this is talking about the 5th percentile. Percentile. That's the area to the left automatically. It's the number below that. So if I'm in the 90th percentile, that means 90% of the people scored below me. Okay, let's keep it pushing. Next thing we want to do is find a value. So we're going to be transforming a z-score into a value. This formula that's given, super duper important. I'm going to encourage you to highlight it. I'm going to encourage you to memorize it. I'm going to encourage you to write it on, I'm sorry, let me speak religious studies. I'm going to invite you to please write this on your note card, because if you blank out and you forget it, you'll always have it. Okay, so we have a vet, and this veterinarian records the weights of cats treated at the clinic. The weights are normally distributed. That's important because that means we can use this formula with a mean of 9 pounds. So that's telling me mu is 9, and a standard deviation of 2 pounds. A little bit of algebra action stuff. So now we're going to use this information and this information, plus they give me the z-score, so z equals 1.96. Plugging in everything I know, and I'm going to find x. So x equals the average, which is 9, plus the the z-score, which is 1.96, times the standard deviation, which for us was 2. Then you'll simplify, and then you'll add, and you'll get 12.92. So what does that mean? This particular cat weighed 12.92 pounds. I don't know if that's big or not because I don't speak cats, but it seems heavy. Okay, try the next one, part B, on your own if you'd like to. You can press pause, give it a shot, and then we'll reconvene. Okay, so plugging in your mean, your standard deviation, and your z-score, you get 8.12. So that particular cat weighed 8.12 pounds. Notice here the connection. When the z-score is more than 1 or more than 0, it's on the right side, so it should be more than the average. If the average was 9, this number should be more than that. This z-score was negative. That means that it should be less than the average being 9 pounds, if you're thinking about that. Good way to just check yourself, make sure you're okay. So what happens when the z-score is 0? Well, when z-score is 0, that means it is average. It's right there, dead smack in the middle of the bell curve. So that means it should be 9 pounds. But you can also just prove it to yourself by plugging everything into the formula. And then you'll still get 9. Okay. Next. So scores for the California Police Officer Standards and Training Test are normally distributed. That's great for them. With a mean, that's important, of 50 and a standard deviation of 10. You can highlight what's important or just kind of extract information that you need. An agency will only hire applicants with a score that's in the top 10%. What does that mean? That means they also need to be in the 90th percentile. What is the lowest score you can earn and still be eligible? So 90th percentile. How did I get that? Well, the top 10%, let's think about this in terms of your curve. That's wonderful. So this is 10%. They only want you to be in here. The question is, what's the lowest that you can get? So what is this value right here? Well, remember when we look this up, we want the area, we want the area to the left of it because that's what our chart is going to give us. So I'm going to do my subtraction just to show you where I'm getting the 90th. 1 minus 0.1, so 90. I need 0.9 on that scale. So when you look it up for the 90th percentile, when you're looking that up, you're going to find that the z-score is not on there of 0.9. But the closest to it is 0.8997. The one after it is just not close enough. So that gives me a z-score of 1.28. That's just the z-score part. Not what I wanted exactly. Now that I have this z equals that, I'm going to plug into that formula that we had. It's at the top of your paper, but it's x equals the mean of z times standard deviation. So for us, if the average was 50 plus 1.28, that's my z-score, times the standard deviation of 10. Kind of do it without a calculator, I'm hoping. 12.8. So 62.8. So what's the lowest score? So let's assume that they only give whole numbers here. The lowest, just to be on the safe side, would be about 63. So there's your sentence. Now, one little thing I want to remind you all of. because your homework deals with quartiles as well. You can kind of look this up yourselves, but just in case, here's our standard thing. This has nothing to do with this last problem, by the way. And we can break this up into quartiles. Remember quartiles, think quarters into fourths. And then this is still 50% here. And then each one has its own 25. So this would be 25, 25, 25, and 25. This is one half, this is the other half. These are also broken down into quartiles. This is quartile 1, quartile 2, and quartile 3, just to remind you. So if I say the first quartile, then in terms of percentages, it's like 25%. So you can look that up, 25%. If I said Q3, or the third quartile, which I could spell, then it would be 75%. Okay, and then Q2 is obviously 50% because it's half. Just remember that, just a little bit of a reminder so you don't have to go back and look it up. Thank you so much and enjoy your day.